All right, I am now on page 805, which is actually part of Module 16, Lesson 3. And we need to go over this little part. Let me move that. Because we just looked at quadratic functions in vertex form, and it was very easy to figure out what the vertex was because it's the ordered pair h comma k. And it was very easy to figure out what the axis of symmetry was because it was the vertical line x equals, it was the vertical line that was x equals h, okay? All right, but what if you have your quadratic equation written in standard form, which is that ax squared plus bx plus c? Could you figure out what the vertex and what the axis of symmetry is? And the answer is yes. It's not quite as obvious, but there is a way to do it. Okay, so the axis of symmetry for a quadratic equation written in standard form is given by this. So it would be the vertical line x equal to negative b over 2a. Remember, b is the number in front of your just x, and a is the number in front of your x squared, okay? Then, could you figure out the vertex if you had a quadratic equation written in standard form? And again, the answer is yes, okay? Your x value is the same as your axis of symmetry, but then your y value is the y value that you get when that's your x value. So that's why they wrote x comma f of x, but remember f of x is y. So you would find your x value by doing negative b over 2a, and then you would put negative b over 2a into the equation for x and generate your y value. Okay, so you can find both the axis of symmetry and the vertex even if it's in standard form. Okay, now the bad news is that this information here is not on the formula chart that they allow you to use for the algebra EOC, so it might be something that you might want to commit to memory. I don't know whether they will do that to you on the star, but you know what? It's always possible. Okay, and last but not least, as part of this screencast, I want to sort of give you guys a little bit of information about why you should even care about quadratic equations in the first place. Well, quadratic equations make a parabola, that curve shape, okay? That kind of looks like a U, but kind of not. Why should I care about quadratic equations? Well, quadratic equations give the equations necessary for instance, the shape of your satellite dish at home, the shape of a curved mirror in a telescope. A quadratic equation models the height or the distance that something falls over time, when accelerating due to gravity, that kind of thing. Those are all really important things that follow the format of a quadratic equation, okay? This in particular, the distance over a certain amount of time, you will see a lot of this if you take physical science or physics eventually, because it's basically a quadratic equation that you have to use to predict how far an object has fallen in a given amount of time. Okay? If you throw a ball up into the air and watch it come down, the path that it follows is a parabola. Okay? So all of those things can be modeled with quadratic equations. Okay?